Hi friends, today we will discuss oscillators. So oscillator means it's a circuit designed to provide periodic output with no input signal. So how can we do this? So this can be done by using an amplifier. So I can simply say that it is an amplifier with positive feedback with positive feedback. So how this can be done? Okay, so we will see by drawing one circuit. So this concept is very simple concept. So if this is input and input is given to amplifier A, amplifier with gain A. So let me write amplifier with gain A, then I am getting output. So let me take this one as input Xi and this is X0, so which is equal to A Xi. And I have a feedback network also. So this is my feedback network. I am connecting here. This feedback network is having gain beta, so I am getting here it is xf as xf is equal to beta times of x naught. So this is my feedback I am getting here. So now I want to convert this, I want to invert this so that it will be converted as the positive feedback, and this I can call it as xf dash, so which is equal to minus xf. Okay, now let me call this point as A and this point as B. So what exactly happens? So I am applying one input and I am getting one output, that is x naught. So I am passing the signal through an amplifier, so I am getting A into xi. So this x naught is I am again giving to feedback beta, so I am getting xf beta x naught, and I am inverting this signal and I am getting xf dash is equal to minus xf. Very simple. So now what is, how can I make it self-sustained? That means how can I make it to provide periodic outputs with no input signal? Means, so as we are giving input signal here and we are getting something here. So now by any chance if we change or if we make this xf dash is equal to xi, that means whatever we are giving the input to the amplifier A, amplifier with gain A, same thing we can produce. Then now what I can do to make it self-sustain, now I can simply connect this B point to A, so that it can be supplied, I mean xf dash is supplied to amplifier A, but now the xf dash is equal to xi, so it will go to another round, and in this similar fashion it will run by itself. So in the later instant you can remove input signal xi completely. Okay, this is what exactly happens here. So now we will see what is the loop gain then. Okay, so as we know that the output is, this is the output of the amplifier and this is the output of the feedback network. Okay, now what is the loop gain then? So simply, what is the loop gain? If this particular thing is there, if this particular thing is there, the loop gain will be equal to xf dash by xi. So I am giving xi and I am getting xf dash, so which is equal to xf dash is equal to minus a beta into xi divided by xi, so which is equal to minus a beta. So this is the main loop gain of this system. For example, if we make xf dash is equal to xi, then we can call this as an oscillator. Okay, so to make that, what we need to do, so this loop gain should be equal to 1 because it is xf dash by xi. So both, if both are equal, we need to get loop gain equal to 1. So this can be written as, if it is a complex form, then it can be written like this. It is a beta angle, maybe let me call it as a minus a beta degree. So Now how can we go ahead about this? This is modulus only, so I can simply write a beta is equal to 1. This is sufficient. This is one condition, it is sufficient for me. And second condition should be a beta angle, so minus a beta angle, and this should be equal to, either 0 or 360 degree, or 360 degree. Okay, this can also be written as, which is equal to, I can call it as, if this is 1, then it should be 1, which is equal to 1 plus j0. So when can we get 0? 0 can be obtained if the angle is either 0 or 360 degree. So now we need to satisfy these two conditions. Our system should satisfy these two conditions so that we can call that system as an oscillator. Okay, and these conditions are called Bach-Hessen criteria. So these two conditions are called Bach-Hessen criteria. So Bar Barkensen criteria. Okay, very simple. Take the loop gain and equal to 0. That's all. Understood? Loop gain means output by input. So the final output is xf dash and the input is xi. So one divided by another one, so that we will get this part. Okay, very simple thing. So then what are these conditions actually? Based on these two conditions, we can have two statements. The first statement will be the frequency at which the sinusoidal oscillation will operate is the frequency for which the phase shift angle theta of the loop gain is 0 degree or 360 degree. So to make an oscillator, we have to maintain the phase shift angle as 0 or 360. Okay, this part is important. And the second point is oscillations will be sustained at oscillator frequency if the magnitude of loop gain is equal to unity. So what exactly happens? He has given explanation for these 2 points. One point is related to angle and another point is related to magnitude. Okay, so these two are the basic conditions to make a oscillator. Okay, so now let us classify these things. Coming to classification, so how to classify these things? So these are very simple. So based upon elements used in the feedback, we are classifying this. Okay, based on elements used in feedback network. So which type of elements we are using in feedback network, so that we can call accordingly. So the first one will be RC oscillator, and second one will be LC oscillator, and third one will be crystal oscillator. Okay, so the name indicates in RC oscillator, R and C elements are there, and these can generate the signals in audio frequency range. That means this can generate signals in 20 hertz to 20 kilohertz. So this is the difference. And the second difference for LC is, LC obviously the feedback network contains L and C elements, and these can generate the signals in radio frequency, that is 100 kilohertz to 100 megahertz. So this is called audio frequency and this is in radio frequency. And coming to crystal oscillators, so the crystal oscillators means the feedback network uses piezoelectric crystals, okay, to generate the oscillations, and these things are in within the range of 10 kilohertz to 10 megahertz. So this is the range of crystal oscillators. So they can produce the signals any of this range. Okay, so these are the basic classification of oscillators.